Okay, good evening, geometry students. I appreciate you finding time in your busy schedules to get your notes taken care of. Tonight is September 11th. These are the notes for tomorrow's class, September 12th. Now we're going to be switching gears just a little bit here. We're still in Unit 1, so all of this information is building towards a Unit 1 test at some point. But you will see that the last part of this unit is going to be quite a bit different from the first part. Not quite as much geometry vocabulary, but still some important things in Unit 1. And we're going to start it off by talking about different types of reasoning. Now, if you haven't done so already, you need to do a summary on the previous lesson in your Cornell notes. So scan back over that information, write a couple of sentences that summarize the information that you learned, and then drop down a couple of lines, and your new objective is the student will discover the similarities and differences between inductive and deductive reasoning. Again, tomorrow's class date would be 9/12 if you want to put that over on the right-hand side next to your objective. As always, press pause anytime you need extra time to copy the notes, and then press play when you're ready to go again. All right, now the topic of reasoning is kind of a lot of people would call it common sense if there is such a thing these days. Okay, but common sense evolves from really a discussion of reasoning, and here is a basic, kind of a synopsis here. Reasoning is an invaluable skill that humans have. It is our ability to logically reason our way through things that makes us intelligent. And we use terms like intelligent all the time. I think everybody's had, or seen pets or something like that, and we've said, wow, smart dog, or wow, that's a smart cat, or something like that. And typically, the things that we are observing that we're placing a statement like that on is their problem-solving ability, that they come across some kind of an obstacle and they think at a higher level than we anticipate, and that causes us to say that they're smart. Well, basically, they are reasoning their way through a situation, and we have the same ability. That's why humans are considered to be an intelligent species, because of our problem-solving ability. We can reason our way through things. And basically that comes from we observe our surroundings, we make statements about our observations, many times without knowing all the facts. Now, it's obviously not a real smart thing to do to arrive at conclusions without knowing all the facts. But let's face it, a lot of times all of the facts are not available to us. We have to do the best that we can based upon what we do know and what our prior experiences tell us about a situation. Okay, but making statements about our observations without knowing all the facts is an example of what we refer to as inductive reasoning. Inductive reasoning is making a prediction based upon an observable pattern. Pause the video if you need more time. These predictions that we make, another vocabulary term, is conjecture. These predictions are called conjectures. Conjectures are, for as far as we can tell, these are factual statements, things that we believe to be the truth. If any situation exists that disproves a conjecture, okay, or proves it to be false, then the entire conjecture becomes false. Such a situation is called a counterexample, or another term is a non-example. Okay. We all know people that do this on a daily basis where you can tell them an entire paragraph and they will pick on one tiny little detail in the paragraph and use that one detail and say, no, 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 that little part was wrong, so that makes your entire statement wrong. And it kind of drives people nuts when you do something like that. For example, they may be picking on the fact that you were wearing a brown shirt on the day that something happened, and when the shirt really didn't have anything to do with the situation. Okay, so it's kind of in a lot of ways considered to be an irrelevant detail or a non-important detail, but in mathematics there is very little that is irrelevant, very little that is not important. So if we can come across even a little detail about a statement that is inaccurate, then that entirely goes against the conjecture and disproves the entire thing, and they're called counterexamples or non-examples. Okay, now let's look at some examples of deductive or inductive reasoning, pardon me. Okay, we use inductive reasoning all the time. Okay, here is an inductive reasoning statement. The sun has risen every day of my life, so the sun will rise tomorrow. Okay, seems safe enough. It is an observable pattern. Every day the sun comes up. Okay, so we get accustomed to this fact that the sun does rise every day. So a reasonable and logical statement would be to say that the sun will rise tomorrow. Okay, but the fact of the matter is do you know that the sun will rise tomorrow? Okay, no, we don't. Okay, it actually takes light 8 minutes to get from the sun all the way to the earth. So the fact of the matter is our sun could have gone supernova 7 minutes ago, and we would not even know it yet. Okay, so we don't know that the sun is going to be there tomorrow, but based upon the pattern of it rising every day, our prediction would be that it will rise. It should rise tomorrow. Okay. This is one I always kind of throw out there. People always get a kick out of it, but it's absolutely the truth. Walking home Tuesday, I saw a dog. I reached down to pet it, and it bit me. The next day, I saw the same dog. I reached down to pet it, and it bit me again. The next day, same thing. So if I see the same dog today and reach down to pet it, it will bite me. Okay. Well, the fact of the matter is, do you know that that dog is going to bite you? No, we do not know the dog is going to bite us if we do this in the future again, but based upon the observable pattern, we would have no choice but to make that prediction. Okay, some of you have a real dog bite type problem in your school and personal lives, continuing to do the exact same thing wrong, expecting a different result each time. Okay, inductive reasoning should tell you if you don't make a change, you're going to experience the same result each and every time. Okay, now conjectures are usually written in what we call conditional format, and you should have seen conditional form or conditional format probably quite a bit in your science classes. A lot of your experiments are written in conditional form, and conditional format says really very plainly and generically, if P, then Q. Now, what's this P and Q nonsense? Well, P and Q are just like a variable, okay? And it represents some statement. If, and there's going to be some statement about something going on, then there's going to be some information that kind of summarizes what we believe will happen. If P, then Q. The information that is going to become P, okay, along with the if, is what we refer to as the hypothesis of the statement. The information that is associated with then and Q is what we refer to as the conclusion of the statement. Okay, the hypothesis is the if part of the conditional form. It is the part of the situation that is being observed. The sun has risen every day. That is the observation. The dog is biting me every day. That is the observation. The conclusion is the information that's associated with then, the then part of the conditional form. It is the statement or prediction that is being made based upon the observation. The sun will rise tomorrow. The dog will bite me today. Now, another example here, if we are in geometry class, then today is a school day. If we are in geometry class, then today is a school day. Okay, we're going to identify the hypothesis and the conclusion. Well, what's the hypothesis going to be? From the definition above, the hypothesis is the if part of the conditional format. So what is the statement associated with if? We are in geometry class. Okay, we are in geometry class is the hypothesis. It is the observation being made. Okay. So what is the conclusion part of everything? Okay, from the statement above, the definition above, it is the then part of the conditional form. So we look at the statement. What is the then part? Okay, associated with then is today is a school day. Okay, so today is a school day is the conclusion. Okay. Now, nobody told us told us that has to be true, but based upon what we know about being in the classroom, it theoretically has to be true. Now, obviously, we're not talking about Saturday school and stuff like that, but typically speaking, if you are sitting in a classroom, listening to notes, taking a test, doing whatever, then that is a school day. Now, the if P then Q, the conditional form, it's actually just a structure and it is not specific to the order. So nobody is saying that the hypothesis will always be the information that comes first and the conclusion will always be the information that comes last, because as we probably well know in the English language now, there's a lot of different ways of organizing sentences and still saying the exact same thing. English is very flexible and fluid that way. Most other languages have a lot more structure than the English language does. Okay, so let's have a look here. We already looked at if today is if we are in geometry class, then today is a school day. That sentence could very easily be twisted around and without changing its meaning and say today is a school day if we are in geometry class. Okay, well, nothing has changed here. Okay, we are in geometry class is still the hypothesis because it is still the observation. Today is a school day is still the conclusion, since it's the statement being made about the observation. Now, one thing that you might notice between this example and the way that it was worded on the last screen was this one, the then is gone. Okay, and that it can potentially happen depending on how the sentence is worded and structured. Okay, but the if is kind of a dead giveaway. That is the conditional part of the sentence. If is a tough word to get around in the English language. It's pretty much the only one that does what it should does this. Suggests that hey, here is a condition, and the condition is what. Okay, so look for the if. The information that's associated with if will be the hypothesis. The other information will be the conclusion. Okay. Now, as we said, counterexamples work to disprove conjectures. If we can find any case where a conjecture is false, then it makes it entirely false. Okay. So let's see if we can figure this out here. Okay. Taking the same information but twisted it up again, this example is going to be if today is a weekday, then it is a school day. Okay? If today is a weekday, then it is a school day. Now, if our goal is to decide if this statement is true or not, okay, then what we are basically doing is we are looking for situations that could disprove this statement, this example. Okay, so the question is, do situations exist where this is not true, that today is a weekday, then that makes it a school day? Yeah, I think there's probably several that you can come up with, and hopefully some of you are thinking them already. Okay, and probably the one that stands out the most to students is the idea of holidays. Okay, those holidays, we do have holidays like Thanksgiving. Thanksgiving is always on a Thursday. Okay, is Thursday a weekday? Absolutely, it is. Okay, are we ever in school normally for Thanksgiving? Of course not. Okay, so yeah, holidays, teacher work days, summer vacation days, there's a bunch of different examples you can come up with along those lines that would make this statement false. Okay, so those are counterexamples. And if you can find even a single solid counterexample to go against a conjecture, then that makes the entire conjecture false. Okay, now the final type of reasoning, there's only two that we're working on, inductive and now deductive. And deductive takes a lot less time to explain. Okay, this one is based upon facts. Okay, so deductive reasoning is the concept of facts based upon other facts. If you've ever heard the saying or seen the little game or activity or whatever called 6 degrees of separation, okay, this is based upon deductive reasoning. It is connecting information to other information based upon facts that you know about the two pieces of information. Okay, so let's just say here, let's go fact. You are in Mr. Hill's geometry class. Let's face it, if you're listening to this video and you are not in my geometry class, then that's kind of silly. But you're listening to the video, taking notes because you are in my geometry class, so that is a fact. Now, Deductive reasoning would allow us to make connections to other things in this world, other things that we know, based upon the statement that has already been made. You are in Mr. Hill's geometry class. Now, there's about 1,000 different ways you could go from this thing, a lot of different information you could possibly pull in. I'll just give you a couple, and so you can get the idea. Okay, using deductive reasoning, okay, you would be able to say something like, okay, if you are in Mr. Hill's geometry class, well, your brain would go, all right, Mr. Hill is a teacher at Odessa High School, so that means you are also at Odessa High School. That means you're a Bronco. Okay, that is deductive reasoning. The statement did not have anything to do with the mascot of your school, but based upon the information that you know about the original fact, you are able to safely arrive at that conclusion, and it is a true statement. Another deductive reasoning. Okay, here you are sitting at home, taking your video, or in the library, whatever, taking your notes. And since we are on the big push for Cornell notes, your notes are in Cornell format. Okay, but again, that doesn't have anything to do with the original statement. It is simply factual information that can be arrived at based upon other knowledge about the fact. Okay, so as I've been saying, none of these things had anything to do with the original statement, but they are facts based upon what we knew about the original statement. Okay, that's basically it. All you had today was inductive and deductive reasoning. No real new geometric vocabulary, no new shapes or anything like that. But based upon the quiz that we took today, you probably need to spend a little bit of quality time working on your notes, maybe make yourself some flashcards, do whatever it is that you need to do in order to get your vocabulary going on, because I believe with these new terms that we just put in here, I believe we're up around 30 different pieces of vocabulary, and we're only 2 weeks into the school year. This can get really out of hand really fast, so do not let it get ahead of you. Stay on top of that vocab.